Logistic regression. So far, I have learned what is linear regression, which forms the equations like w1 x1 plus w2 x2 plus up to plus wn xn plus the bias, which produces a regression value. But logistic regression is also regression, but it squashes the value of this between 0 to 1. So it uses something called a sigmoid function, which squashes the entire regression value to a probability. So we can predict a class. So for example, we have a classification task of two classes. It is called binary, and n classes is called a multi-class. So let's say we have an example, weather example, where we have to predict whether the day is a sunny or a rainy. And for if we have two classes, it's called binary classification, and for more than two classes, it is called as multi-class classification. So how does logistic regression works? So let's say this is the sigmoid function 1 plus 1 upon 1 plus e to the power minus c. So it squashes the logit. This is the logit. This logit into a probability. So if the probability is greater than 0.5, we predict class 1, or else we predict class 0. As this works on a simple formula where if my logit is greater than 0, the probability will be greater than 0.5. If my logit is less than 0, probability will be less than 0.5. If logit is equal to 0, probability will be equal to 0.5. We can take a simple example. If my logits are plus 100, so 1 plus e to the power minus 100 would be a very small value. So neglecting it entirely will give me 1. 1 plus 1 plus 0 is 1. But if I have a value negative logit value, it would be very infinite value. So 1 by infinity would be 0. So if I have a very high number, let's say here it would be close to 1, now it would be close to 0, and the base probability, where 1 plus e to the power minus 0 would be 1 plus 1, which is 1 by 2. So the probability would be 0.5. Now let's say we have done some predictions using this logistic regression function. So my model learns a line similar to what linear regression is doing, but here the line separates the two classes. So the distance between the class 1 samples and class 2 and class 0 samples should be maximum. Why maximum? Because it helps the model to separate out this class as well. So the distance is maximum. The distance from the decision boundary for a classification task is maximum. Now, how do we measure the accuracy of the model? So let's say for given a task of weather prediction, so a model has, let's say, 5 examples, 1 2 3 4 5 5 examples, 5 input values. Let's say 1 1 0 0 1, right? And the model predicts 1 0 1 0 1, right? So how do we measure the accuracy of the model? Let us discuss first the accuracy, right? So this is a correct prediction. This is also correct prediction. This is also correct prediction. But see here, this is a mistake and this is also a mistake. But they are not same type of mistakes. Like one predicted as 0 and 0 predicted as 1, both are mistake of a model in predicting the class, but it's not the same type of mistake. Why? Let's understand the first the accuracy, then we'll come to that. So accuracy is simply like selecting the what threshold should be my optimal threshold. For an example, what threshold separates out the classes, class 1 from class 0? It is by 0.5 is by default, but we can set any value. Let's say 0.24, 0.73, whichever threshold gives me sorry. So here the y prediction would be, sorry, I can write this, but my predictions from my model predictions would be in probabilities. Let's say 0.5 is 0.6, we have 0.43 here, here I have 7.2, here model predicts 0.32 and model predicts 7.9. So as the probability was greater than 0.5, we predicted as class 1. Here the probability is less than 0.5, we predicted class 0, and so on for the each and every value of y. But which value is the best threshold value for the model? Which value separates out the classes? For that, we look at the ROC AUC curve. It generally tells us that how many class 1 values, class 1 predicted probabilities are having higher, how many class 1 probabilities are higher than class 0. How many times the model predicts the class 1 probabilities higher than the class 0 probabilities. Let's say the model has made 100 predictions, and out of 100 predictions, model has given higher probabilities to class 1 73 times, and for the remaining 27 times it has given higher probabilities to the class 0, right? So what does this 73 and 27 tell us? So the number of time model predicts higher probability, let's say 0.6 and 0.3. The model only predicts one value, let's say 0.6. So if a model is predicting 0.6 and it is a class 1 label, and if a model predicts 0.7 and it's a class 0 label, so it's a mismatch. So it should not happen. So class 0 should not get such higher probability according to the formula. So we need to check the overall ability to how my model is able to classify the class 0 from class 1. The only way to check the model accuracy is through the predicted probabilities. So we take the predicted probabilities belonging to class 1 in one array, sort them out and draw a ROC graph. So let's say we have some predicted probabilities in sorted order. for the class 1 labels, and we just draw a connect them using a line. So for each and every threshold predicted probability, we calculate how many class 0 probabilities are lower than this value. Similarly for this, similarly for this, similarly for each and every value. And we calculate the total average, how many of the class 0 probabilities are lower than class 1 probabilities, or we can say the number of times the class 1 probabilities are higher than the class 0 probabilities, right? So if we draw a graph and connect the dots, the area under the curve would be the AUC and the curve would be called as ROC. So let's understand through this an example. For the weather prediction, let's say my model predicts 0.6 for rainy, where the rainy is the class 1, and 0.3 for sunny, which is class 0. But what if the model predicts 0.64 for sunny, right? And sunny is my class 0. So model is not able, so model has not optimized optimize the weights well, and so I am getting a higher result for the class 0, higher probability for the class 0. So my weights are not optimal. So to understand whether the learned weights are the accuracy of the learned weights, how much accurate my model is, the only way is to plot the probabilities and check the average percentile. This is called the average percentile. Let's say number of class 1 probabilities are, what is the ranking of class 1 probabilities, then how many times the class 1 gets a higher rank than class 0. It is a simple thing. Let me change this element. Right, average percentile of class 1 against class 0. How many class 1 thresholds are above class 0? Model is able to separate the classes well on average. So how does the model calculate the loss? Based on a log loss. So simply, why not MSE, and why using the different log loss function, as MSE cannot be paired with the sigmoid function. Why? Let's have a look over here. Let's say my model prediction is 0.01% for a positive class, so it is a high error wala class, so model should get a high loss and a high gradient. But when we calculate the gradient, the derivative of sigmoid function and the derivative of the MSE function into the derivative of the weight with respect to the output. So when this is calculated, so the derivative of sigmoid function is sigma into 1 into sigma. Then for the MSE function is 2 into y minus a, as y is my predicted and y is my actual. But here if you notice, because sigma is a into 1 minus a, if you multiply 0.01 into 0.09, what do you get? 0.09. And even when you multiply this with a smaller value than 1, the gradient becomes very, very small because of this a1 minus a. We just need the 1 minus a, or we need the y minus a. We don't need this multiplication. So if you take the log loss for an example, Here a and 1 minus, so the derivative of log loss is y minus y prid, y prid upon 1 minus y prid. If you take this sigmoid and this a into 1 minus a gets cancelled out, and we are only left with y minus y prid, that is 1 minus 0.01, and we get a higher value of 0.99 as a gradient. So log loss is used just to penalize the higher. And what are the limitations of logistic regression? The limitations of logistic regression, it is very sensitive to outliers. Sigmoid is insensitive to probabilities either close to 1 or 0. Gradient is close to 0 for such outliers for correct classes. So let's say y minus y prid is 1 minus 0.89, which 0.11 into derivative of loss with respect to w, it's very less. So sigmoid is a curve like this, so a value close to here and close to here will not make much of a difference in the weight updates, and it should be because the curve is like this, it should be like this, but we should not have very outliers like class 0 label here, class 0 label here, class 0 label here. It should be separable, like class 1 and class 0 should be separable, linearly separable, because my algorithm learns a linear line. It just squashes every value between 0 to 1 to predict the probability, but the data should be linearly separable. Draws a linear line to separate the classes, cannot handle non-linear patterns. Yeah. So if my pattern is like this, or where the class 0 lies here and class 1 lies here, so the logistic regression cannot create a line like this. It would be resulting in very low AUC accuracy. So this was the logistic regression. There was one thing left, which is the mistake, not the same type of mistake, which I'll be discussing in the second video.